Welcome to part 2 of our video where we are converting a tic-tac-toe board game to play against the computer. So let me start and show you where we finished last time. So last time we added a logic for the computer to play the center board. Right, now let's continue. And let's make sure there is a get computer board logic. So this is where we are. Here we are playing the computer board logic, right? But here one thing we forgot to do, right? We can only make this move if board 00 is equal to board 01. We are trying to make a move here 0, 2, but computer cannot make an illegal move. So we need to add another condition. Only play this move if this board is empty. Otherwise, your computer is going to make an illegal move, and there's no point. Your program is going to have a problem when the computer starts making illegal moves. So similarly, you need to add a check here too. Just copy this condition here. Now remember, we are using if then else conditions here, right? But there are more sophisticated ways where we can play a tic-tac-toe. One of them is building like a tree, a B tree we call it, that can have any number of nodes, but that's a complex data structure and we haven't discussed data structures in this class. That's more of a topic for an advanced class. But that is the way this should be done, because in that way the computer will try every move and figure out a move in which it has the highest probability of winning. But those are more sophisticated techniques, and this is a beginner level video we are doing, so we'll stick with the simplest approaches using if then else. Alright, so we checked for this condition and we are looking for the aggressive moves. Again, we need to add a condition. I mean, we can't make illegal moves here. So let's copy this if condition here. If board 1, 1 is, oh, actually here we don't need that because we are checking that in the beginning. Alright, so this is board 1, 1. So if board 1, 1 is occupied, let's look at other choices we can do. If board 0, 0, take this one. This is a pretty good one, which means the corner. Right? And then we can also check the other corners. So this is row 1, try column 2. This is row 2, try column 0. So you're trying to take some of the corners. Comma 2. Alright, let's see, run this up and start the game. Let's see if the user takes a player. So the computer will automatically take this move over there. Now what if a user makes this move? Oops, why is the move not allowed? So looks like this move is coming because the computer is trying to make an illegal move. So let's go and check this logic again. When we are getting computer move is equal to 0, let's start playing with this. Start game. So let's see, we make a move here, everything is fine. Computer makes a move here. Now let's try to, user tries to make a move here. If board 00 is equal to O, let's look at the position of the board. Yeah, board 00 is equal to O, so we cannot make this move. So let's continue. So it's going to make a move here. Okay, so let's try making aggressive moves. See, if board 0, 0 is equal to blank, so it's going to make a move here. So let's get inside here. If allowed, move row comma column. Row comma row is equal to 0, column is equal to 0. I think that was the user move though. We'll have to check and play that again, because if you look at the board, 0, 0, 0, comma 0 is already occupied. So why did our updated board return 0, comma 0? So let's take a look at our logic. This is the problem, right? We had an error here because we are playing 0, comma 2 and we put 0, comma 0 here, and same here, same here. So as you can see, putting breakpoints is so useful. It helps you in debugging the program. Let's start the game again. Let's make this move. Let's remove the breakpoint for the time being. Oops. There we go. We make a move here, and then if we click here, the computer made a move here. But that's a mistake, right? Because computer should have made the move here, so the user is going to play this one. But it's happening because our defensive moves does not have a check for this. So once you add the defensive move checks here, the computer will actually play the move here. All right, let's resume here. If I play this move here, the computer makes a move here. If I play here, the move is not allowed. Basically, maybe because we haven't added a checks for that. There's no possible move available. So let's go back to our get computer move. So let's first do this. Let's make the defensive moves into a loop to make things easier. So let's first check for each row. It's less than 3, I row plus plus. And let's make this condition generic. So if row I row comma 0 is equal to a row is equal to 0, and then we are checking if I row is equal to I row comma 1, and then checking. So it will automatically check every row and figure out the third column. Now again, you have to also account for conditions where if I board row is equal to 0, we are only checking the first column, but you may have to add a condition on the second column too. So do remember that. Now in this case, we don't need this condition here. And let's add a new condition for a column. So we are checking if the row 0 of the column is equal to now some of the checks here will be redundant because there'll be a same mapping here. That is fine. And you're only going to make this move if I see row is equal to 2. Similarly, you'll actually have to add a check here for different combinations when different rows and columns are selected. Alright, now we are doing the aggressive moves, so we are taking care of the columns. And finally, let's add a condition here that if if we are still at this point, play in whatever cell is available. So let's add a logic here. Just simply, so we basically just have to check each row and column. I row is less than 3, I row plus plus, and then we'll add another one for the columns. Now again, note here I'm declaring these variables directly inside the loop. So if you declare it that way, as soon as it exits out of the loop, the variable cannot be accessed. But again, you can also declare the variables outside. Sorry, I column plus plus. Let's add a braces here, and we'll say if board I row comma I column is equal to this, is if the board is available, just play that board. Now again, this should be done as a last resort because you are not determining if there's a user has a move in which the user can win, and you're not aggressively trying to win. So hopefully you have enough conditions here that will take care of the board state and you wouldn't have to resort to this, but this is just a fallback option. So let's make this move. What was rc dot row is equal to I row, rc dot column is equal to I column, and return rc. Alright, so this way the computer now can play any move. If none of the intelligent moves above are satisfied, it's going to take whatever board is whatever cell is available. So let's run this code. Alright, so I start this, computer makes a move here, computer makes a move here. Now obviously we haven't added the selection logic here, so let's click somewhere else. Computer makes a move here. So game has ended because player 1 has won. But here you see the player actually made their move first before the game was determined to have been ended, right? So what we need to do is every time the user makes a move, we first need to check has the game actually ended, and there's no point for the computer to play, I mean, if the game has already ended. So to do that, what we need to do here is go back into our get updated board logic. Before we do this, we need to check has the game ended or not. So remember, if we go back on the form, we are doing the checkboard here. So let's find this. I press Ctrl F there. So we are checking the board and we are displaying this message here, has game ended. Right, now if the game has already ended, how do we display the message board? So let's come first check. And then what we can do is where is a logic? If check so What we are seeing here is that we are kind of entering into a logical trap here, because the messages that we are displaying when the game ends is displayed from a form. So let's actually do this. Let's not use this function here. Let's not make the computer move automatically from within the class, but let's have the main form make the computer move. So obviously when we are coming here on the update board, let's see where. So picture one dot click, it's as soon as the user clicks on the board, we call this function called update board, and then we get the updated board state, and then we use that board state to update. Now you are only going to come here on the update board function if the user clicks, right? So now you draw the board after the user moves. Now you can say now play computers move, and you're going to get computer move, so you need to give main board. Oops, get computer move is a private one, so let's make it public. There we go. Here is we don't need all of this because we know player one has already moved, and so now we get the computer move, and the computer move is going to be independent. So as soon as we get the computer move, we are going to update the board again. String board is equal to, and then we take the value from the computer move and then do rc.column here. So board has already been declared on the top, and now we take a look at this. When the board comes, we just simply draw the board. And now when you draw the board, you should also check if the computer move has actually won the game. If main board.check board is equal to true. So at this point, if the game has ended, the player wins. And you can add the name of the player here, and then you can say game has ended, computer wins. So you don't need a function to return the name of the winning player. So the tic-tac-toe board has this function here, get winning player name. Well, there was another function here called set winning player. So we don't need to set the winning player here. But where is this function being called? So if you right click and say find all references, so we are checking the board and we are calling this function from here, but I don't think this needs to be done here. Alright, let's build the solution. Build successful. Now let's see how this runs. Let's start game. Player one move. Player one. See, the computer is not playing aggressively. It should have selected this board. Oh, we haven't added the check here, so let's play this. Player wins. Aha, it's also displayed. That also allows the name of the player to, of the computer to play. So there's a check we need to add here, so that as soon as the player one wins, go back to a form. If we display this message, the game is pretty much ended, right? So we just need to finish the game. We don't need a return here because this is the end of the function anyway, but if you're just trying to be consistent, just add the function here. Alright, in the next video I'll show you how we can do more fine-tuning here. So let's just make sure that everything is good. player wins and the game has ended. Now, one thing you will have to do is once the game has ended, you should not be allowing any more moves here. So we'll also take a look at that, how to add that logic in the next video.